All right, this is AP BC Calc. We're doing a BC only section. This is Unit 10, Section 3, the nth term test for divergence. So, given an infinite series, the sum from n is 0 to infinity, or n is 1 to infinity, or n is 7 to infinity, it doesn't really matter. Those couple finite terms at the beginning are sort of irrelevant, of a sub n. The nth term of the series is whatever this a sub n is, right? So my bad, ignore that. So for example, the first term would be a sub 0, and the next term would be a sub 1, and blah, 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 and then a sub n, right? Okay, so, and again, this could start at 0, it could start at 1, it could start at 7, it doesn't really matter because the first couple finite terms don't matter. If the limit as n approaches infinity of a sub n, so this term, if that's not 0, right, if the terms way down the line are non-zero, then the series has to diverge, and we'll talk about that in a minute. So note that we can't draw any conclusion in the other direction. If the limit as n approaches infinity of a sub n is 0, we don't know anything. It could converge, it could diverge. We're going to have to use other tests on the checklist to see if something it gives us a conclusive answer. So all this tells us is if the nth term, right, way down the line as n approaches infinity, if a term way down the line is non-zero, then the series has to diverge. Let's talk about why this makes sense. So you're adding infinite terms. So if they're non-zero, right, then you are summing infinite numbers that are not 0, and so you must get something infinitely large. Let's say every term in a series is 1. 1 plus 1 plus 1 plus 1 infinitely many times is an infinitely large value. Let's say every term was much smaller. Let's say it was 0.00001. Okay, infinite many of those 0.00000, whatever, it doesn't matter how small you make it, infinitely many of those is still going to be an infinitely large value. So essentially the only way that an infinite series can even have the possibility of converging is if those terms way down the line as n gets huge, as n approaches infinity, if those terms are 0. So we're going to apply the nth test for divergence. So this allows me to either say that the series diverges or state that the test was inconclusive. I cannot know anything with any certainty if this thing doesn't diverge. So if the test is inconclusive, then the series might converge, it might diverge, but we just don't know any other tests yet. So as we move forward in later videos, you'll learn other tests to do this. But for right now, you only know this one test. Technically, you also know about geometric series, but none of these are geometric. So the limit as n approaches infinity of this nth term, right? Well, because this is an n to the first and this is an n to the second, that's going to approach 0. So this test is inconclusive. I don't know enough, right? I don't know if this converges or diverges. I'm stuck. I would have to use other tests later to figure out if this converges or diverges. But you don't know those other tests yet. So for right now, you're just going to say the test is inconclusive. Okay, so same thing here. The limit as n approaches infinity of an n over an n squared plus 1, right? Well, all we really care about as we approach infinity is these leading coefficients. So this is going to behave like a 1 over an n, basically, because it's an n to the first over an n squared. So this is also going to go to 0. So this test is inconclusive. I can't do anything with it. I don't know whether this thing converges or diverges. I just know that this test didn't help. All right, so nth term test. Limit as n approaches infinity of a 4 to the n over a 3 to the n, right? Well, this is a 4/3 to the nth power, right? This is a number that is greater than 1, right? And you're putting it to a power, so it's growing, right? It's getting bigger, not smaller, right? Like as I put it to these powers, it's getting bigger. So this is infinitely large, so knowing that it's definitely non-zero, right? Sorry, there's a limit as n approaches infinity there. So it's definitely not 0. It is going to be infinitely large, but what I need to know is that this thing diverges, right? So this is the piece of information that's important here. That is definitely not a 0. Now, if you're not sure with the infinity thing, you could actually try it. You could say, hey, if n is 1, it's this. If n is 2, it's this. If n is 3, and you can get pretty quickly, you can figure out, oh, hey, this is getting bigger. This is not approaching 0. Like they're getting bigger, right? These are not getting smaller. These are not numbers that are getting closer to 0. They're numbers that are getting bigger. All right, so if we apply the nth term test here, the limit as n approaches infinity of a 3n cubed over 7n squared plus 2n. Again, remember, we're almost always only concerned with the leading coefficients. Since the 3 is bigger than the 2, this thing's going to be infinitely large. It's not going to be 0. Like, this is going to be infinitely large because essentially this is like a 3n cubed over a 7. So it's not the same as, but it's like a 3n cubed over a 7n squared, which behaves a lot like a 3n over 7 or a 3/7 n. So again, as n approaches infinity, this is getting huge. So this thing diverges because remember, the nth term test for divergence just says that if this whole thing is not approaching 0, then the series has to diverge. All right. Let's try again. So the limit as n approaches infinity of an n factorial over a 2 to the n. Now, this one's a little bit harder because, honestly, it's hard to picture which one's sort of growing faster. One way to do it, so if you're ever having trouble with this, is you can just try some numbers. You can say, hey, what happens if I pick n as 1? I get a 1 factorial over a 2. If I pick n as 2, right, I get a 2 factorial, which is 2 over a 2 to the second, which is 4, right? If I picked n as 3, I'm going to get a 6. That's 3 factorial over an 8, right? If I pick n as 4, I'm going to get 4 factorial, which is 24 over a 2 to the 4th, which is 16. So what I want you to start to notice is that suddenly this is getting bigger, right? At this moment, this thing became bigger than the other thing. Now we'll see if it stays bigger, but when I do 5 factorial, right, I get a 120 over a 32, right? 6 factorial is a 720 over a 64. So this is getting way bigger. So this thing is definitely not approaching 0, right? So this is bigger than the denominator. So at first, they look like they're fairly small fractions, but we can kind of use numbers to infer, oh, hey, this is not approaching 0 because these values are getting bigger. So if that limit is not, so as n gets big, then this a sub n is also getting huge, right? But again, it doesn't matter that it's getting huge. It matters just that it's non-zero. All right, we're going to go ahead and try again. The limit as n approaches infinity of 3n over the square root of 6n squared plus 4n plus 5. Okay, so this behaves, right? It behaves like the leading coefficients, which are these guys. This behaves like the limit, so it's not that it's equal, it just behaves like the limit as n approaches infinity of a 3n over a root 6n squared, which is the same as a 3n over a root 6 times an n, meaning this behaves like a 3 over root 6, which is not 0. So this thing is not 0. Like the limit as n approaches infinity of this thing would be the fraction of those leading coefficients. This thing is non-zero, so this thing diverges. Again, all we care about for the nth term test for divergence is whether this thing on the inside approaches 0 or not. All right, so for E4, we're going to do that nth term test again, right? So we want the limit as n approaches infinity of 2n plus 1 over 5n plus 3. And we've seen all the way back in Algebra 2 that really what this means is we're looking at the fraction of the leading coefficients, and this is a 2/5, which is not 0. What that means is that this thing has to diverge because you're adding essentially way towards the end, quote unquote, which there isn't really an end because it's approaching infinity. You're going to have 2 over 5, 2 over 5, you're going to keep adding 2 over 5 forever, and if you add an infinite number of 2/5, so you're going to get something infinitely large. So last problem, P4, same thing. You're going to do the limit as n approaches infinity of this 9n squared minus 3n plus 10 on top of a 3n squared plus 2n plus 7, right? And so again, I'm looking at the fraction of the leading coefficients. They have the same degree, so this is going to end up being a 9/3 or a 3, which is not 0. So again, as you get way down the line to those infinite terms, you're adding 3 infinitely many times, and so this thing diverges, and that is the end of 10.3.